Hello everyone, welcome to the solution of Leetcode problem 543 named diameter of binary tree. In this problem, we are given a binary tree and we have to return the length of the diameter of this tree. Anyways, the definition of the diameter is the diameter of a binary tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root, and the length of a path between two nodes is represented by the number of edges between them. Anyways, let's consider the first example. Here we are given a binary tree of the root 1, which has two children, which is 2 and 3. 2 also has two children, which is 4 and 5. And the diameter of this tree is 3 because the longest path between 4 and 3 exists 3 edges, which is 4 to 2, 2 to 1, and 1 to 3. So the diameter of this first tree is 3. I hope you understood the first example. Now the constraints are the number of nodes in a tree can be in between 1 to 10 to the power 4, and the value presented in each node can be in between -100 to positive 100. I hope you understood the problem statement. Now let's move on to the algorithm. In this problem, let's consider the first example. The root of this binary tree is 1, which has two children, which is 2 and 3. And 2 also has two children, which is 4 and 5. Anyways, we have to now calculate the diameter of this binary tree. For the simplicity of the algorithm, we will use the depth first search algorithm, which is DFS algorithm. And at first, in the DFS algorithm, we will visit the current root, which is 1. Now, according to the definition of the DFS algorithm, after visiting one node, we have to explore its left subtree. So, from the node 1, we will move to the node 2, which is the left portion of this tree. Anyways, node 2 also has two children, which is 4 and 5, which is still not visited. So we cannot process node 2 right now. So according to the definition, we have to move on to the left child, which is 4. So currently we are at node 4, and the left and right child of this node 4 is null. So currently we have to explore the left subtree according to the DFS definition. But unfortunately, the left subtree is null. So from this, we have to return 0, which is the base condition of this recursive algorithm. So the base condition is if we reach any node which contains the value null, then we have to return 0 from this node. Now, again, we are in the node 4, and the left portion of this node 4 is processed. So we have to explore the right portion of it. So currently, we will move to this node. And unfortunately, it is also null. So again, we have to return 0 from here. Now, for this node 4, all of its left and right subtree is processed. So we should process the node 4 right now. So now the equation is we have to return the value of 1 plus maximum of the left child value is 0 and the right child value, which is 0. So we have to return 1 from here, from node 4. So node 4 is returning value 1 to its parent, which is node 2. Anyways, we are currently presented in node 2, and all of its left subtree is processed. So currently we have to explore the right subtree of node 2. So we have to move on to the node 5 from the node 2. And node 5 also has two children, which contains the value null. So according to the DFS algorithm, from the node 5, we will move to its left child, which contains the value null. Eventually, this will return the value 0, to node 5. And after returning the value from the node 5, we will explore its right child, which contains the value null also. And it will also return the value of 0 to its parent, which is node 5. So currently, all of its left and right subtree is returning the value 0. And according to the definition, node 5 will return the value of 1 plus maximum of its left child value, which is 0, and its right child value, which is also 0. So node 5 will return the value of 1. Now, currently we are presented at node 2, and we have explored all of its left and right subtree. The left subtree of node 2 is returning the value 1, and the right subtree of node 2 is still returning the value 1. So, according to the equation, node 2 will return the value of 1 plus maximum of 1 and 1, which is 2. So, from here, node 2 will return the value 2. Now, currently we are at the root node, which is 1, and all of its left subtree is processed. So we have to process the right subtree of node 1. So from node 1, we have to move on to node 3, and I am not repeating the algorithm here. From this node 3, its left and right child value is null. So both of them will return 0. And the node 3 will also return the value of 1 plus maximum of its left child value, which is 0, and its right child value, which is also 0. So node 3 will return the value of 1. So it is returning the value of 1 here. Now, for this root node 1, its left child is returning the value 2, and its right child is returning the value 1. So node 1 will return the value 1 plus maximum of 1 and 2, which is 3. So we can say that the diameter of this binary tree is 3, which is this path. I hope you understood the algorithm. Now let's move on to the code. In this code, at first we are given a function named diameter of binary tree. The parameter of this function is the given binary tree. Inside this function, we will use a depth first search algorithm. The parameter of this DFS function is the current binary tree. And outside of this function, we will declare a global variable named result, which will store the diameter of the tree. And after our DFS function completes its iteration, then we will return the result. Now, inside the DFS function, if the current root is null, then we have to return 0. After that, we have to recursively call the DFS function from the left subtree and the right subtree. And when we explored all of its left and right subtree, we have to update the result for the current node. The updated result is the maximum value of the current result value and the left and right child value. After updating the result, we have to return the value, which is 1 plus maximum of the value returned by the left subtree and the value returned by the right subtree. And the equation is 1 plus maximum of left and right. After that, we have to return the result. I hope you understood the algorithm. Now let's move on to the time and space analysis of this code. Here in this algorithm, the time complexity is big O of n, because in the DFS call, in the worst case, we have to visit every node exactly 1 time. So if the number of node is n, we have to determine the time complexity as big O of n. And the space complexity of this algorithm is also big O of n, because the space complexity basically depends on the function's call stack. And in the worst case, the DFS function call stack contain all of the n nodes. So here the space complexity is big O of n. I hope you understood the time and space complexity. Thank you everyone for watching this video. We will get back soon with another Leetcode solution.